Hey, in this video, I'll demonstrate how to use YugabyteDB Voyager to perform a live migration from Postgres to YugabyteDB. Let's get right into it. The database that we'll be migrating is the popular Northwind Database, which was originally developed by Microsoft and has since been ported to Postgres and a variety of other databases. This is a sample schema for a fictitious company called Northwind Traders, and it's a sales schema with various tables for categories, products, suppliers, orders, etc. It's worth noting that YugabyteDB also lists this Northwind sample database under our documentation, and you can find that under sample datasets. I've written an application which executes writes. More specifically, it executes orders against the database. So we can use this in order to show how a live migration of data works from Postgres to YugabyteDB. So let's look a little bit into how the live migration process works. The live migration feature of YugabyteDB Voyager is actively being developed and is currently in technical preview. Let's go over the live migration workflow here by reviewing this diagram. So suppose we have an application like the command line application that I'm going to show shortly, which points to a source database, in this case Postgres. Our data can be exported first by exporting a snapshot of that data, and then any writes that are being executed on the source database thereafter will constantly be added to an event queue. So importing data to the target, YugabyteDB, occurs by first importing a snapshot and then continuously draining this event queue until it is emptied, in which case the application can then be cut over from pointing to the source database to then be pointing to YugabyteDB. So we can show this illustration here, which provides all of the steps for using YB Voyager for a live migration. This is very familiar to those of you who are familiar with the offline migration process. It involves first, of course, installing Voyager and preparing your source and target databases, which is essentially just the process of creating users and giving them the adequate permissions to both export and import data. The schema is exported and can be analyzed and modified. So if there are any issues with the schema upon export, those can be found and changed before importing to YugabyteDB. But this middle section here is the process that I just described, where the data is exported and imported simultaneously, and changes are being added to a queue and drained from the queue. The cutover process both stops the export of data from the source, from Postgres, and when cutover completes, the application can then be pointed to YugabyteDB. Then when the migration has completed, we can end the migration and take any backups of logs or data as we see fit. So let's start this process by running a migration assessment to see what sort of database makes sense on the YugabyteDB side based on the size of the database and the workload being run upon it. The migration assessment provides us with a lot of very good information prior to actually kickstarting the migration process. It allows us to have a bit more visibility into the compatibility of our source database, allowing us to understand whether or not there are going to be any unsupported features during the migration. For instance, certain data types might not be available in YugabyteDB that are available in Postgres, Oracle, or another source database. Another really cool feature of this tool is the cluster size evaluation, which will provide us information about the size of the YugabyteDB cluster that would be recommended based on certain metrics on the source database. And the schema is evaluated to let us know any sort of sharding strategies that might be recommended, as well as various performance metrics and an estimation of how long this migration will take. Because I'm running YugabyteDB locally on my machine in Docker using YugabyteD, we have access to a UI that is specific to migrations, and this UI is actively being developed just like the tool is. We currently have no migrations running, but I'll be able to show how the migration analysis report populates in this screen, as well as any other additional details about the schema or the data throughout the process. So why don't we hop over to the terminal and actually generate some operations on the database. So this simple Node.js script that I've written generates writes on the orders table of our Postgres database. I've also chosen to deploy Postgres in Docker on my machine as well, but have verified this migration using Amazon RDS for Postgres. So I can run this script and 100 writes are being executed per second to that orders table. So now we can run the assess migration command on the Yugabyte Voyager CLI. We can see here that we've specified the source database as Postgres and provided information to connect to the database, as well as specifying the export directory where we want this report to be sent. So we can run this command now, and this will just take a moment. So I will be right back and we can review this report. The migration assessment has completed and is available in the export directory in both JSON and HTML formats. As I mentioned, this report is also being integrated into the YugabyteD UI, so let's review it there. This is a very simple schema, so we don't have a ton of recommendations. We're seeing that the instance type that is being recommended for our YugabyteDB cluster is a 4 virtual CPU and 16 gigabyte of memory 3-node cluster. And we're recommending that we use 14 co-located tables in this deployment. We can see that we have some recommended refactoring. No manual refactoring is being recommended, so all of our DDL statements should automatically be imported to Yugabyte. However, I'm going to show how we will eventually review this schema before importing it to Yugabyte to make sure that everything looks how we want it to look. We don't have any unsupported types, which can often be expected because Yugabyte is working towards Postgres parity. And we have some unsupported features that we want to make note of that we will be sure to rectify throughout this process if necessary. This is just a bit of information to give us a baseline prior to creating a Yugabyte cluster and providing us some recommendations. We also have a schema analysis report that will be generated after we export our schema. So we have multiple levels of intervention throughout this process to make sure that we are migrating a schema that we are happy with. So let's go ahead and do a schema migration now and walk through that whole process. We can now execute a schema migration using the CLI in a very similar way that we did for our migration assessment. Here we're specifying the export directory yet again and our connection details for our source database. So we can run this and it will almost immediately complete because we have quite a small schema. And now we can analyze the schema and make any changes that we might see fit before importing to Yugabyte. So let's run yet another command to analyze the schema that we've just exported. Here we're specifying that we want the schema analysis to be in text format. And once again, we have exported something to our export directory here. This can be found under reports. So let's go over and check out this schema analysis report in our text editor. Here in Visual Studio Code, I am showing the schema analysis report, which is not reporting any issues. All of our tables will be able to be imported to Yugabyte with no issue. But we can see here we also have a schema directory with all of the different object types that can be imported. Materialized views, schemas, sequences, triggers, and so forth, all of the various language features. So let's check out these tables that are part of the schema to be imported. I want to make a change to this schema to show you how that process works. I noticed that the orders table uses a small int data type for the order ID. So were our business to have a ton of orders, this would become a problem. So I wanted to update this to be a big int to be used in our YugabyteDB instance, so that when I'm running the application, if I should run the simulation for a very long time, I do not run into any issues here. This is just an example of how we can intervene. We can review this schema that is going to be imported to YugabyteDB prior to doing so. So let's go ahead and actually import this schema to Yugabyte now. Now I'm going to import our schema to Yugabyte. I have a YugabyteDB instance running in Docker, much like the Postgres instance. I've also created a user for the migration and granted the privileges necessary, just like I did for Postgres. So we can run this import schema command of the CLI, specifying the target database now, not the source database. And we can see that the various tables are being created on the YugabyteDB side. And we're all set. Now we can begin to execute the live migration of our data. In the Yugabyte UI, we can see that our schema migration has completed successfully, moving over one schema and 14 tables without any suggestions or errors to note. So now we can move on to data migration. In my terminal, I've split the windows so that we can run the data export in the top pane and the data import in the bottom pane simultaneously. So let's run the commands to make this happen. So first, I will start the application to generate writes on our Postgres instance. And then we can use this command, export data from source, to export data from Postgres in the snapshot and changes export type. So this, as I mentioned previously, will create a snapshot of the data in the database and use any changes coming in to populate a queue on disk. So we can run this, and we see the data export has begun, and a snapshot is created with many orders in it. Now, as orders continue to be captured, they will be exported as events in our queue. So now, while this is running, we can import data to target using YugabyteDB Voyager to YugabyteDB. And running this will show that the snapshot is being applied to Yugabyte. And soon we will see a table, just like we're seeing above in the import, where these events are being drained from the queue. You can see here that total events imported is already 3,900. And we only have a few left, so this queue will be drained very quickly, and we can initiate cutover and switch our application to point from Postgres to YugabyteDB. So let's go ahead and do that now. I've decided to split the pane one more time so that we can see these processes completing. And we are going to run the initiate cutover to target command. When we run this, we will be stopping both the import and the export. And we can see that the queue has been drained effectively. It is caught up very quickly after stopping writes on our source database. So now we need to very quickly go over to our application and point to YugabyteDB so that our application writes are now being processed on a new target database. Before doing so, let's go over to the shells and confirm that each database has the same number of orders to verify that the cutover has in fact worked properly, migrating all of our data. So here we have the Postgres CLI open, and I'm just going to count the number of orders. We can see we have 31,827. And we would expect the same number here in Yugabyte, and indeed we do have the same number. So now we can go over to our application and change the environment variables for our connection details. We were previously connected to Postgres, and we can change this to point to Yugabyte instead. Now switching back to our terminal, we can rerun the application and see that writes are seamlessly being written to Yugabyte now and not to Postgres. So we can verify this by showing that we have no additional writes to Postgres, but we do in fact keep rolling in writes to Yugabyte, and we have successfully migrated our database to Yugabyte. So now we only have one thing left to do. We have an additional command where we can take backups of our logs and data and so forth, as well as cleaning up our source and target databases. So let's go over that and wrap up this process. Now we only have one thing left to do, and that is to run the end migration command in Voyager. So I'm going to do that now. Here I'm specifying the export directory where the data will be read from. And I'm going to back up log files and data files and also schema files, but I'm not going to save the migration reports. We specify a backup directory where this data will be sent, and we can run this now. The migration cannot be resumed or continued after this, so we will confirm. And this will, in fact, initiate the process. So we need to provide the password to connect to Postgres in order to clean up this source database. So I will provide that now. And the same needs to be done on the YugabyteDB side. So I will provide the password for the user YB Voyager. So this has completed, and the data will be stored to the backup directory. So let's show that now. So we have data, logs, and schema. So let's check out the logs directory. Here we can see that we have logs for every step of the migration process. And we have backed up our schema and our data as well. So that concludes the live migration process from Postgres to YugabyteDB. Performing a live migration from Postgres to YugabyteDB is no problem with the help of YugabyteDB Voyager. But if you do happen to run into any issues, you can always reach out to us in our community Slack. And also, please be sure to reach us on GitHub and give us a star. Thanks a lot. Have a good day.